Hello, welcome to Advanced Algebra 2. We're gonna factor. Oh, are we gonna factor today? And factoring's awesome. Hey, at the beginning here, I've got a couple quick factoring patterns that you must have run across before. One is called difference of squares. The other is called perfect squares. And the nice thing about these is that they're kind of shortcuts that can make your life better, but they're really not necessary. So if you never ever saw them and you always factored everything the hard way by guess and check, you can still do that and it's just fine. It's a little tedious and long, but it's fine. But what we have new today are these called the sum of cubes and difference of cubes. Now, these you're probably going to have to learn because there's just no way of randomly guessing it unless you really notice things. But really, you're probably going to have to learn them, which is just fine, I hope. And we got the patterns there, and I could read them for you, but you can read yourself. And we got some examples, so let's do them now. The examples are going to be all mixed up, and that's because factoring problems come all mixed up, and I need you to recognize the patterns as they come across. Hey, look at this. Okay, first example. C cubed minus 729, and hopefully you see the C cubed, and you're like, that's a cube. I hope the other one's a cube. And the answer is, it is. It's 9 cubed. And you wouldn't necessarily know that immediately, but you'd guess and check a little bit. You're like, I don't know, it's 10 cubes 1,000, so it's less than that. And I don't know, 5 cubes 125, so it's more than that. And you figure your way out. Okay, now since it's a difference of cubes, we'll use that little difference of cubes pattern. So C minus 9, and then C squared plus C times 9, plus 9 squared. And then write it out like we know what we're doing here. C minus 9, C squared plus 9C plus 81. And that's it. Boom. Okay. That's one idea. Here's the next one. Ooh, fun. Lots of 5s, lots of J's. Now, this one has a common factor, so we'll want to start with a common factor, and it's 5j squared because that can be divided evenly into each term. Okay? Now, looking at the j cubed plus 1,000 in the parentheses, you're like, haha, that's a cubed thing, and oh yeah, 10 cubed, yup, with a plus, there's a thing for that, and there is. So, 5j squared still sitting outside, being patient, and j plus 10, and then j squared minus j times 10 plus 10 squared, and you'll need to write it like a human being at the end. So j plus 10, and then j squared minus 10j plus 100. Common factor first, always common factor first. I would have said common factor first on example 1, but it didn't make any sense because there were obviously no common factors. So here we go, an answer. All right, next one. 6x squared minus 27x plus 200. Now, you can totally just run away and guess and check on this, and that's fine. And, if you've got a good... Well, people used to watch TV shows. A TV show in the background, you could do it, or something. I don't know if it works with YouTube in the background. Who knows? Anyway, so you try this. But, just humor me now. The first question you might ask yourself is, I don't want to spend my time on this if it's not going to work. So, does it even work? And the answer to that is the discriminant. If you've got an incredible memory, you might remember this from graphing parabolas when we were doing x-intercepts, and I was talking about, hey, you can pretend to factor. Well, here's what we're going to do. We're going to pretend, at least at the beginning, just to see if factoring even works, right? So, the thing under the square root in the quadratic formula, the discriminant, b squared minus 4ac, put in the numbers, and you get 729 minus 80, it's just 649, and then you see if that's a perfect square, and in this case it's not, so it's not a perfect square, which means the polynomial does not factor. Now in parentheses it says over rationals, because, now follow along just briefly, you could use the quadratic formula, and since we know the discriminant is 649, we know there would even be real answers, but doing the square root on that as part of the quadratic formula is gross. So technically there are irrational numbers you can come up with, and then in pre-calculus you will factor over this anyway, but it's basically cheating and pretending by using the quadratic formula on the side. Anyway, look, it doesn't factor for us, advanced algebra 2 style. So we call it prime. You did that in algebra 1 also. Just please, please, please be smart enough not to write prime as a default when you're just feeling icky and you don't want to do the work, right? Actually check it out and know when things are prime and when they're not. Okay, here's another example. And we're going to do the same basic idea. Does it factor? So the discriminant is b squared minus 4ac. That's, hasn't changed for a couple years now. I got negative 56 squared minus 4 times 9 times 12. And, that's 2,704 overall. And that is 52 squared. So this one does factor. And we know this because the discriminant ended up a perfect square. That doesn't, unfortunately, really tell us how to factor it. So we know it does factor. Now, if you hate factoring, in this case, you can always cheat and do the quadratic formula on the side and then write it down and pretend. But I'm supposed to be helping you learn to factor. So let's remind ourselves. Okay, we got x squared, so we got something x, and then minuses because the constant's positive, but the middle term is negative, the linear term. So that meant it was two negatives, because then they'll add and be negative, but they'll multiply and be positive. Oh, good times. Okay, so you gotta try stuff, like maybe 9 and 1 for the 9x squared. If we run through our options and that doesn't work, we can do 3 and 3. Oh, goodness gracious. Okay, so 12. 1 and 12. Give it a try, and you kind of go choop, choop, choop with your head and your brain and your calculator, and you're like, no, that doesn't work, right? Because the middle term would have been, what? No, we got 9 times 108, and then one more, negative 109. That's no good. No good at all. So, sad face. Okay, get rid of that. Try again. 12. I got 2 and 6. 2 and 6 is here. 54, and then 2 and 56. Yes, it works. It works. Now, what I could have done is I could have done that thing teachers do, where like I try everything except the thing that works until the very end. But that's really annoying for everyone involved. And you guys are too smart. What you need to know is I got kind of sort of lucky, or you got kind of sort of lucky, as we made this happen quickly instead of longly. I don't know. So be glad, but know that there are so many more options that could have been tried. So the answer is 9x minus 2, and then 1x minus 6, or just x minus 6. Boom. Okay. Ooh, look at this. A's and B's. Now, there's A's and B's everywhere. Factor out A's and B's. In fact, you can factor out a squared and b squared, because each term has at least an a squared and a b squared in it. And that leaves b squared for the first term and a squared for the second term. The minus still. Difference of squares. Right there. Yep. B minus a, b plus a. That's it. Zoom. Super awesome. Okay. 81x squared plus 108x plus 36. Okay, 9. 9 can factor out. So 9x squared plus 12x plus 4. Now you might say, okay, well, I'm going to set it up in 9 and 4. Could do the discriminant first to see if it works. And it does. Actually, the discriminant's 0 if you tried it. And that's because, check this out. I'm seeing stuff with the 9 and the 12 and the 4, because that's 3x squared, and this is 2, 3x and 2, and 4. 4 is 2 squared. That is a perfect square. It's 3x plus 2 times 3x plus 2. Now, this takes a lot of practice to recognize the first, when you run into it. I'm pretty sure I never would have noticed this when I was in high school. So what you could always do is kind of go back to the other method where you try some guessing and checking, or you do the discriminant first to see if it's even worth your time, or if you just want to get it done and you don't like frustration, you just do the quadratic formula on the side and pretend. But boom, it actually is 3x plus 2 squared with a 9 in front. Yeah, you probably noticed it. Oh well. Okay, so next one. Wait a minute, we got a lot of things going on here. But if you just look at the first part and then leave the y squared alone, That's x minus 5 squared. Now, be honest, you noticed that. Yeah, you did. So that's x minus 5 squared. Yeah, my squared. Oh my gosh, that's the difference of squares. We had like a perfect square, and now we have a difference of squares. It's x minus 5 plus y, x minus 5 minus y. One thing squared minus another thing squared. Good stuff. Okay, that's worth a box. Absolutely. All right. Are you joking? To the fourth? Ooh. This is a dirty trick. You take x squareds, and instead of x's, you make them x squareds, and then you're like, boom. It factored. But it's fourth. Yeah, but you just make them x squareds, and it all works out. It only works out because the middle term is x squared, right? If the middle term was x or x cubed, or goodness gracious, if there was some sort of combination between them, it would be a disaster. But here, that actually worked. And I'm pausing because there's more, because it's a difference of squares. X plus 3x minus 3 and x plus 2x minus 2. Wow. That's awesome. Okay, this has been too much awesome. So what I'm going to tell you is the assignment in class, and again, this is for in class. Don't need to do it now. You can start if you want, but whatever. Will be these. Thank you for watching, and as always, please let me know if you have any questions.